Did a factory default password really let $12,000 drones walk into a plant that upgrades $45 million bombers? You clicked for answers. This is the Taganrog raid that clipped Putin's nuclear wings. We'll show how a hangar door code never changed from default opened the way for an FPV swarm, why S-400 and a Pantsir S-1 couldn't stop low, quiet, networked attackers, and how a few pounds of explosives turned two Tu-95s into vaporized write-offs. Stay, because the exact breach, the blind spots, and the 58,000% ROI are all on tape. Before we move on, please take a moment to subscribe to the channel and like the video. A door code on a hangar control panel sat unchanged for years, not because no one knew how to change it, but because no one saw the need. At the Taganrog plant, the job was pushing Tu-95s through upgrades and inspections.
According to reports, Ukraine struck aircraft included Tu-95.
The whole question of escalation leading to further escalation is a pattern that nobody wants to see.
Which Russia has relied on to fire long-range missiles at Ukraine throughout the war.
The place kept Russia's long-range bombers flying, so the focus stayed on airframes, engines, avionics. Access control should have been the first gate, the thing that stops casual mistakes from becoming national losses. Instead, a factory default became the quietest insider anyone could ask for, and a single keypad held the cheapest key to a $90 million bay. The plant's role made it a hub for heavy work. Engine overhauls, wiring harness replacements, new navigation suites, and corrosion checks. Each bomber rotated through dedicated bays with strict schedules. That rhythm created habits. Workers tapped the same pad, opened the same sliding doors, and got airplanes back on the line.
Is Russia's strategic nuclear-capable Tu-95MS bomber.
It might say what we're seeing on one hand is jockeying for position. Who's going to have the stronger hand to play?
The Tu-95MS are designed for long-range missions.
Security meant perimeter fences, watch rotations, and the big comfort blanket, outer air defenses sitting miles away. If the sky was locked down, the thinking went, small errors on the ground wouldn't matter. That belief held until a reported default hangar door password did exactly what it was designed to do on day one. Accept entry, no questions asked. The attackers brought a swarm of 20 FPV drones, each about 5 pounds. That size keeps noise low, battery life workable, and handling tight in close quarters. Operators saw what the drones saw through low-latency feeds, which let small explosive charges become surgical tools. You don't need a suitcase bomb when a shaped charge placed against the right panel cuts the brain of a machine, and a small thermobaric puck next to an oxygen manifold turns maintenance clutter into fuel. The human factors made it easy. Maintenance crews got measured on throughput, hours per airframe, work orders closed, downtime reduced. Cyber hygiene sat at the bottom of the checklist. No two-factor prompts on the door controller. No mandatory credential rotations. Logs that showed door opens, but not who, not why, and not whether a code had been changed since installation. When the line is busy and bonuses hang on deadlines, no one volunteers to break a workflow for a security update that can wait. The cost curve was brutal.
With a range exceeding 14,966 kilometers, allowing them to strike targets globally.
Russia's almost certainly going to respond with an even greater military force.
Now, its large size allows it to carry a significant payload of 20,000 kilograms.
The swarm drew from off-the-shelf frames, budget flight controllers, and basic scripting to coordinate entry and targeting. The price tag hovered around $12,000. On the floor were 2 Tu-95s valued at $45 million each, plus stands, test gear, and specialized tooling. The math favored the attacker before the first propeller blade turned. This is what asymmetric looks like when commercial parts meet strategic assets. The first defensive stumble came fast. Inside a hangar, a shoulder-fired IGLA with a 500-meter minimum range is basically a museum piece. You can't lock a small, slow, agile target at 40 meters without frying sensors or hitting a wall. Gunners hesitated, then backed off. Nobody wants to punch a hole in a bomber with a stray missile. That pause was all the drones needed. Once the door slid and the swarm crossed the threshold, the geometry flipped.
This is clearly a major escalation on Ukraine's part. There's been discussion that Russia has begun its spring offensive.
Line-of-sight routes ran between scaffolds and ducts. Ceiling cameras tilted too slowly, leaving blind angles along beam lines. A guard had to call a supervisor, who had to unlock a case, who had to sign off on using a weapon indoors. The procedures were built to stop theft, not a networked set of machines weaving through a forest of equipment. The mini payoff lands here. One unchanged password opened the path, and everything downstream lagged. Static defenses watched a moving problem and never caught up. Entry was only phase 1. The real test waited outside the walls, where S-400 and Pantsir screens looked for big signatures and missed the smarter route that was already inbound. Why did $500 million in air defense watch a flock that wasn't a flock? Because the stack was built to see threats that behave like missiles and jets, not a dozen small machines that act like wildlife.
And now the Ukrainians showing that they can retaliate. So where this goes from here, and dealing a significant blow to the Russian military capabilities.
The outer ring sat with S-400 batteries handling long-range search and track. Closer in, Pantsir units guarded the approach lanes with rapid-fire guns and ready missiles. Around them, electronic warfare crews blanketed the coast with jamming meant to crush consumer radios and drown control links. On paper, the grid looked tight. In practice, each layer assumed the next would mop up anything that slipped through. The swarm played the map, not the briefings. Drones skimmed low over the sea of Azov, staying inside the radar shadow where curvature hides small objects. Ground radars saw clutter and reflections off chop. Operators watched returns that looked like birds drafting along the shoreline. Then the climb started at the worst angle for a turret. A narrow 15-degree cone where elevation drives run behind tracking, and Traverse can't whip fast enough to place lead on targets that keep changing height. Deception carried them farther than speed. The operators had trained a biomimicry model on local traffic camera footage from Taganrog. The flight paths mimicked the jitter and arcs of the region's birds, including those odd wind-driven stalls you see near cranes and roofs. It worked so well, a real eagle broke off its own patrol and went after one drone, convinced it had a rival in its airspace. Humans on consoles saw something that matched what their eyes expected to be natural, and they hesitated for the beat that matters. The first intercept came from distance. A 40N6 went up, forced by a controller who finally flagged the pattern as inconsistent with birds. The missile didn't have to hit to do damage. Its launch split the swarm. A few drones died in the shockwave and the subsequent flak envelope, but the rest peeled into fragments and kept moving. Command links stayed alive because the network wasn't a single chain. Resilience sat in the radios. Each drone hopped across 900 megahertz, 2.4 gigahertz, and 5.8 gigahertz, switching 18 times a second. The spread beat simple spot jammers and forced any reactive system to chase ghosts. Offshore, a relay mothership acted like a mesh hub. It stitched torn packets into full frames and pushed a clean stream back to pilots. The backhaul rode a tight directional laser link, so the coastal jammer never saw a wide lobe to blind. Broad-spectrum noise did degrade margins, but guidance stayed inside the window needed for terminal runs. Inside the hangar, the math changed from range to placement. Small charges went for oxygen tank clusters first. A shaped jet vaporized the steel, spiking a localized thermal event hot enough to slice through the Tu-95's aluminum skin. JP-8 needs the right heat and oxygen to flash. The attack delivered both at the same point. The chain reaction moved down lines and into bays, feeding on what the maintenance schedule had staged for the next shift. Final strikes finished the job. 6 FPV units rode straight into engine blocks with shaped charges set to punch through compressor faces and mounts. The hits forced structural members to take loads they couldn't carry as heat-warped beams. Sections of the roof sagged, then folded. 2 bombers went from repair assets to write-offs in minutes, and the bay turned into a dead zone for recovery crews. Past the flames sits the ledger. A low-budget swarm generated a return measured against airframes, tooling, and weeks of lost throughput. The modernization pipeline didn't just pause, it jammed. Restarting means new parts, inspections, and trust, rebuilt in systems that failed under pressure. while the next route in is already being mapped. The sharpest weapon here wasn't blast or fire. It was a default password, paired with smart routing and comms that refused to die under noise.
So in the ground war, Russia was gaining and is still gaining until this latest round of attacks. Clearly, Russia had the leverage. It's just a very, very crucial moment and a very, very dangerous one from the standpoint of ever coming to an end to this war.
That mix turned static defenses into props and stalled a bomber line without a grand budget or a signature strike. If a garage budget can choke a strategic assembly line, what other crown jewels sit still and exposed? Comment your next target class: logistics hubs, radar nodes, or leadership luxuries, and why. We've entered an era where wind, physics, and code beat price tags. So who adapts faster now? The defender tied to sunk costs, or the attacker armed with open source tools?